In this video, we're going to talk about a new form, which is vertex form of quadratics. Before watching this video, please attempt this question 876. So if you started now, go ahead and pause the video, see what you remember from the last two lessons, and complete 8-76. And once you're done, come back and check the answers. All right, hopefully you've had time to answer the question and you're back checking your answers. So I found each of the components that we need in order to graph. The four things we want are the y-intercepts, x-intercepts, line of symmetry, and vertex. So I started with the y-intercept. The y-intercept is 6. I can see that within the equation. It's just the last number. So that's what this 0.06 means, and I plotted that point. The next thing I found was the x-intercepts. I pulled out a GCF of a 2. I wrote its factored form. And I found that the x-intercepts were at -1 and -3, and I plotted those points. The middle of those two is -2, so I did the dotted line in the middle, and then I plugged the -2 into the equation. So the -2 should have went right in for the x's, and then my output became -2 as well, and I plotted that point. My last piece was to reflect this point over so that I have 5 points, and there is my graph. So that's what we have been learning in the last two class periods. Today we're going to talk about another form, and we're going to see why do we need another form. So in 877 it says use the zero product property. That just means factor. See if you can factor x squared minus 3x minus 7. Go ahead and pause the video and give that a try. Alright, so I went ahead and factored it, and as I was factoring I realized that I can't factor it. This problem is not factorable. There aren't any factors of -7 to add to get -3. So what happened? The problem was not factorable. What does that tell you about the result? It tells me that the roots are not nice numbers. What that means is it's not going to be crossing at a whole number like we have been finding. It might be crossing at a decimal, location, or just something that cannot be factored. Okay, so using your graphing calculator, which we're going to use Desmos, display the graph of this. Did the graph confirm your answer to part A? Okay, so I'm going to pull up a Desmos and show you the graph of it. Okay, I'm going to try to bring over the graph. I have it typed into a Desmos. Hopefully you guys can see this graph. And when I'm looking for the roots are, looks like it's at -1.5 something and 4.5 something. So we can write those numbers down as the roots. And as we were talking about, those are not nice numbers. These are decimals that we cannot write as a fraction. Okay, so that's why it's not factorable. These are crossing at non-whole numbers. Okay. So yes, this answer would be confirmed. The roots are not nice numbers. And then to estimate, I think we said -1.5 and 4.5. How could you estimate the roots? By looking at a table. Don't worry about that question because I'm not making you make a table. 876 wants us to estimate the roots. We are going to cross this part out. 876, all you would be doing is typing those in. And looking at the crossing points where it crosses the x-axis. That's all it's asking you to do. Okay, so we're going to cross that part off. Let's move to the back page. So on this page, what it wants us to do is to start by verifying that this is a quadratic equation. All right, so this is a quadratic, and I'm going to show you that it's a quadratic by switching it from its vertex form, which it's currently in, to its standard form. And the way that I would do that is just order of operations. Okay, so if I was to multiply this out, my first step would be the exponent. I have to expand that. And if I multiply that out, x minus 2 squared means x minus 2 times x minus 2. If I multiply that, I get x squared minus 2x minus another 2x. So that's going to be minus 4x and then plus 4. And then I still have the 3 in front and the minus 5 at the end. So now I have to distribute the 3, and I get 3x squared minus 12x plus 12 minus 5. And then these two are like terms, and that changes to 3x squared. 3x squared minus 12x plus 7. So hopefully you guys would agree that both of these are the same, and I can confirm that with a Desmos graph, and I'll be graphing them here in a second. But another thing that we need to understand is this equation is a quadratic. Here's the other form of it, right? And this is definitely a quadratic equation. Okay, so yes, we verified that it's a quadratic. You're not going to be required to do that step, but you are going to be responsible for answering these questions about something in this vertex form, okay? So we're going to answer those questions about our graph, particularly looking at its equation in vertex form. So I'm going to pull up a Desmos graph, and we're going to answer those questions, okay? Give me a second. All right, I have both of those graphed for you. If I turn off the bottom one, you can see here's the red one, and then here's the blue one. So yeah, those two equations are the same. They're the same graph, right? They're just different forms. Now that we see the graph of them, let's answer the questions on our worksheet. So looking at our questions, is the graph upward or downward? What are the x-intercepts? What is the y-intercept? What is the vertex? And what do you notice about the vertex and the original equation? So take a minute or so and answer the questions that you can without my help, and then resume the video when you need to get the answers to that question, okay? So go ahead and pause now and try to answer those questions. All right, now we are going to take a look at the Desmos and compare these two equations and then answer the questions right here. Hopefully you can see this graph. I think we've already talked about this, but yes, this is the graph of both of those equations. And now what I want to do is identify, is it upward, is it downward, what are those key features? So this one is upward. It's pointing up on both arms. Remember, smiley face is up, frowny face is down. So it's upward. The next question, what are the x-intercepts? So we're going to estimate those. So it looks like it's crossing at 0.7 and 3.3. So those are our x-intercepts. The y-intercept is up at 7. Hopefully you guys notice that in standard form you see this 7, but in vertex form you don't quite see that. Okay, that doesn't really give you the y-intercept like it does in standard form. Okay, and then next thing we want to look at is, what is the vertex? Okay, so what is the vertex of this parabola? And the vertex is 2, -5. So 2, -5. And with that vertex, look at the original equation and see if you notice anything with the equation. Here's the original equation. Do you see the vertex in the equation? I hope you do. The -5 translates with the y value here. And then this says -2, but this says +2. So we need to see, is that going to be consistent throughout? Is it the opposite of what's inside there? Okay. So let's try another one and see if we can answer the same questions about the next one. Okay. I'm going to have you guys take a look at this function, type that into a Desmos, and then see if you can answer all the questions that we just answered about that one. So pause the video and give it a try. Okay, so first question, is it upward or downward? This one is downward. It's facing like a frowny face, so down. Next question is, what are the x-intercepts? The x-intercepts are roughly -5.2 and -2.8. Remember, those are just estimates. The y-intercept, you're going to have to zoom out and go down, and it looks like the y-intercept's at -29. And then the vertex is at -4, 3. Can you see that in the equation? -4 because it's the opposite of this, and then +3. There it is. That's why this is called vertex form, because you can identify the vertex very quickly. The next thing you need to notice is that this is downward, and what's different between this one and the one before it? The one before it, its equation was upward, and see if you can notice a difference of what makes it upward or downward. So this one has a +3 and this one has a -2 to start it. +3, it was upward, -2, downward. So the connection that you should be making is if it has a positive leading coefficient, that's going to make it go upward. If it's a negative, it's going to go downward. All right, without graphing, can you predict the vertex of this equation? So what's the vertex? Okay, well, the pattern that we found is it's the opposite of that. That's the x, and then this should be the y. So it should be -3, 2. One thing that other teachers said, I was talking to Mr. Flynn in the hallway, is he says, what makes this 0? Well, it'd be -3. Kind of like what we were doing when we were factoring. So -3, 2. Next question, let's just do the same thing. Oh, let's go back. Would this one be upward or downward? This one would be upward because it's a positive coefficient. All right, let's take a look at this one. Same thing. What's the vertex? The vertex would be -1, -16. And this one would also be upward because the coefficient's just 1. Okay, so that actually goes down here on what's the vertex. We're not going to find the X-intercepts this time. And make sure you guys circle or highlight this equation. That is vertex form, or another name is called graphing form. We call it vertex just because it gives you the vertex. So what are the advantages of this form? Well, just like I said, you can easily identify the vertex and if it's upward or downward. All right. We're going to stop there with the worksheet, and now what we're going to do is just look at a Desmos graph and make sure you understand some key things about it before doing the Desmos activity. So here's my Desmos graph, and here's the same equation that we were looking at. So let's notice a couple things. I can make the equation go upward by changing the negative. So do you see that? If it's negative, it's downward. If it's positive, it's upward. I can change how wide it is by changing this value here. So it is a 2 right now. If I change it to a 5, look how steep it got. If I change it to a 10, look how steep it is now. If I change it to a 0.5 or a 1/2, it's getting wider. If I change it to a 0.3, even wider, 0.1, even wider. So those are some things to remember on how to affect the graph so that you can make those adjustments. In the Desmos activity, you're going to basically be using that concept to make Mario, it's a Mario activity, you're going to make Mario hit all of the coins on the screen in order to progress to the next slide. Okay? You should be able to do the Desmos activity now, so go ahead and finish up this by attaching your notes and then transitioning to the Desmos activity and trying your best on that. Once that's complete, the Desmos activity, your final step would be to do the exit ticket. Hope you found this video helpful, and let me know if you need any help. Thanks for watching.